And we are recording. Welcome to the evening of Python coding. Each month we bring you another Python library that we can talk about, or some sort of tool related to Python. So today, today we have Don Branson, and he's working with all sorts of AI. And he suggested to give a talk. He has many things that he's doing with AI. Some of them are really interesting, but he suggested that something that helped him a lot in some of his AI vision, and it's something called RoboFlow. So Don, perhaps explain to us what RoboFlow does and give us a demo about it.
Will do. So the high-level context for this this project that I did as part of like AI Makerspace Bootcamp was to be able to fine-tune a vision language model to be able to detect blood cells and types of blood cells, etc. So it was a bit of a bumpy ride, and the toughest thing really ultimately came down to the data. And that's where the library that I'll be talking about today helped kind of fine-tune the model and sort of get to the point of like originally, like difficult to see that originally the model before it was fine-tuned, it was saying that it was seeing it as it's like I still think I'm on a Mac when I'm not. Yeah, there you go. It was thinking that in terms of blood cells, that it was seeing jellyfish. In terms of an image that is a diseased liver biopsy, it was saying it was a flower. But after fine tuning, it got much better. And so there was a couple of different data sets that I looked at that helped greatly, but the RoboFlow data sets and also their associated Python library helped the most. So for me, it's like as much as anything, it's their it's their data sets that were helpful. So today what I did is I pivoted a little bit and created a simplified, in some respects simplified notebook, focusing on the data pipeline and going from like the RoboFlow data set to uploading it on Hugging Face. So that's the preamble. Okay.
The people who don't know what Hugging Face is, can you give them a simple overview?
Yeah, sure. And okay. So this is the application that I built that did the fine tuning. It's out on Hugging Face. The other thing is that in terms of when people publish stuff, that it's in the context of spaces normally, but you can also publish and create models. You can publish and create data sets. So that's kind of like in terms of the creators and makers, what they will publish and create. Sorry for the noise in the background. I'll grab the door. Real life, how about that? Okay, so the other thing about Hugging Face that they create is that they are truly, they're not an open source company, but they are a key conduit for publishing open source libraries like transformers, libraries like Path that are used for fine tuning. So they really do it all. And so in terms of Hugging Face, like as I mentioned, that in terms of, it's not letting me. Okay.
Yeah, it's enough. People understand.
But anyway, is that enough? So if that's of interest, we can chat afterwards in the open sort of talk. So, okay, in terms of the notebook.
Can you make it bigger? Yeah.
For you, no. Yeah, for everybody else, yeah. So here, like I always like demos where, if needed, that you can, you can nuke stuff and recreate it all, let's see, that was supposed to be, there it is, outline mode. Okay, so this is kind of the context. It's not complicated, as I said. It's like RoboFlow, which is the library, and it's also the data set. And so this is what we'll be walking through.
Tell them what ETL is.
Let's extract, transform, and load. So anybody want to tell me what ETL is from their perspective? I'd love to open it up.
Data manipulation. It's like extracting data from files, transforming it so a machine learning model or something else can understand it.
Yep. Yeah, I was thinking that the crowd, man, get the crowd involved.
Okay. Oh, I apologize.
Yeah, there you go. And so, for context, the where we're extracting from is, this is the RoboFlow site, and this is the specific data set, and it's like a blood cell data set, and this is sort of, as I was, sort of talking about in the preamble, this is kind of their unique sort of twist. And sorry, it's small, but they sort of take, a generic data set that historically would have been in a format like COCO, which is common object. Don't ask me for more than that. Yes, but there's a lot of stuff sort of mentioned on COCO data sets. And but new models, when you go to tune them, these newer models have very precise and specific formats, and so this is where the work that RoboFlow has done is very helpful. How I actually found out about them was on a paper that was created when Microsoft created their original open source performance model. They mentioned the RoboFlow 100 data set, it's like group of models that they referenced it because it had better non-common object sort of images. So it wasn't images about clothes and other things like that. And some of them were healthcare related. And so the two data sets I've showed quickly, one being the blood cell, the other one being liver biopsy samples, that they are part of the RoboFlow 100 sort of group of image data sets. So click on that. The other thing here is that if you choose to download it, what did I pick? Did I pick? I guess it doesn't really matter. Okay, so this is COCO format, but the other thing here, in terms of starter code, like you pick the model that you want to do, you go continue, and this is, in essence, providing the code to sort of specify the data set that you're interested in downloading. So
hold on, you're showing us the RoboFlow data site, or you're showing us?
No, this is RoboFlow, and so this is part of what's really cool in terms of providing a valuable tool for people that want to work with vision language models, fine tuning, etc. Is that if you find a data set you like, you can go out to the site and pick the specific model that you're looking to fine tune, and it even gives you the starter code to specify the data set and the model format. So they are doing a significant part of the heavy lifting that I was doing by hand prior to this. So it's very helpful that way, and sort of by contrast and comparison is like Palagemma. That was another model that I was looking at, an open source model from Google. And so it's just slightly different in terms of, the starter code, but very helpful. They also have a lot of great videos. I should find that and I'll share it afterwards. I, gave a big shout out and thank you to their developer advocate, because he does some great YouTube videos on a number of vision models, including stuff from Meta, like Segment Anything. So before I jump into the code, are there any questions, comments?
So far you showed only the RoboFlow, that it gives you models. What else does it give you? Data sets? I saw some data sets.
Well, as I said, it gives you okay, so it's not a model. They are data sets that are specific to a required model format. Does that make sense? That's a great question. And so
there are different models that they offer you and different data sets, and do they help you make them compatible, or what's going on there?
Well, so compatibility in this case, and so this is, and I'm beginning with the end in mind and going to the reading the end of the book before I tell the start of the story. But these models, these vision language models that you're trying to tune, the format that they expect is very specific, and so it's like although they look very similar in terms of Palagemma and Florence 2, there are key differences. Like the Palagemma does things like like in an image, right? You can have that relates to blood cells. You'll have multiple cells, right? And so each of those is an annotation on the image, and the annotations, when you compare the two, are very different, both in terms of how they delimit and separate each annotation. The other thing is that they're also very different in terms of, like if you've seen a typical bounding box definition, what I remember, it's standard 640 by 640, that there's also very distinct differences in how both Palagemma and Florence 2 sort of say, hey, this is where this specific object is in the picture, and where to place a bounding box. So it's like
okay.
Yeah.
So you're saying that they speak different languages. And therefore RoboFlow helps you comprehend them, or like translate it to a unified language.
Okay. So what this is, and what we're focusing on in this workbook, is just a simple ETL process from like the RoboFlow data set, which is like, and there's like two data sets in this case. There's like one data set for each model that we could choose to fine tune, and then we're loading it to Hugging Face. And so this is the sample data that they've provided and it's a typical split train, test, and validation. But this is this is the secret sauce, and this is what's helpful, is that that the format, they've already done the heavy lifting to convert it to a format that you can already use to fine tune a model.
Okay, so let's go over the code slowly so people understand what's going on.
For sure, but this is kind of the punchline, and this is kind of where you kind of lead up to the fact that you can see that it's the same image ID, right? But even though it's the same image ID, it has the format is different, and also sort of this is the only thing. This number is the same, but aside from that, how they declare sort of the location of where these bounding box and where the sort of cells that they're creating these bounding boxes around, that the syntax is completely different. So okay, so yeah, in terms of the code, it is it's Python code. So the Python libraries. So RoboFlow, that's the that's the vendor that has both created library to access the data sets when you're doing fine tuning. They also have methods that one of the key methods is supervision that helps provide better visibility and control of specific fine tuning exercises. But for today's talk, I'm not going to go into it. Data sets, that's a Hugging Face data sets library. Python.env, that's just for environment variables for like when I was loading it. Visual Studio Code, and then Matplotlib and Seaborn, so visualization type libraries. So, okay. So for configuration, because this was standardized, that one of the things I did is I created a config class. And so that, if I come back and want to change, the specific project, which is, this is an example, this BCC data set is a project. If I wanted to change that, I could just use this standard sort of config format. So yeah, so the RoboFlow 100 workspace, here's the project. And this is the standard location that I wanted to bring it down to. And here's where I'm indicating that I want both the Palagema dataset format and the Florence 2 format. Okay, and this is because nothing ever works the first time, this is the glorified reset button to make the dataset folder so that it runs cleanly again. And then, so this is the preparing the data sets. I standardize this because at least in terms of the high level sort of structure, like when you're creating a data set for fine tuning, uploading it to a place like Hugging Face, that for a vision model, for object detection, you care about the image ID, you care about the actual image. In this case, it's like a byte encoded image, and then the annotations. And so we can go down and sort of look at that, but it kind of breaks it down into three parts, like the image, the prefix, and the suffix. So the image string. So one of the things in terms of where I got the the identifier that I chose to use rather than generating something new, I just used the the image ID property from the data set that was part of the annotations. So so this is loading the data set handler. That's the overall section. And then within the handler, telling it to download the data set and prepare the data set based on some of the specific formatting. And yes, okay, so, okay, what the heck? So you only live once. That's it's time for nothing up my sleeve. Let's clear all outputs and time. Start session and run on. So part of the reason why I'm doing this is that this isn't sort of the first sort of set of data where I ran into this, but there was a slight difference in the folder structure. So here for Palagema, based on where they had what's called the annotations file, which is it's a special JSON. It's JSON, but it's JSON in a list format. Okay, it's RoboFlow API key does not exist. Okay, well that should not be happening. But okay, that is because I am Also, if you run it in the right environment, I do not have a RebelFlow API. I do have it here. Okay, let's try it again. Okay, sorry about that. That's where I was just validating the link that I shared. Okay. So yeah, so this is in terms of if you're looking later. So here's the data sets folder. It's Florence. Okay, yep, it hit the reset button. So there you go. Okay, so I can refresh it. Are most people familiar with Google Colab? And you can just check it if you get people to post in.
You can tell about it. It's some people are not, most people are, some are not. Tell what Google Colab is.
Okay, so Google Colab, it's like open source Jupyter Notebook, more or less. It is a platform where you can run data science type code in a notebook format. So it's like Python, where you have instead of just doc strings to document code, you've got Markdown that sort of wraps specific blocks of Python code. So that's kind of what it's about, and that's key reason why I chose to sort of update it and share it this way, is that others could, then take it, play with the code and make it better. Yeah. So in terms of preparing and downloading the code and downloading the data set, and sort of the outline is that Florence 2, for the Florence 2 model, when it creates it with test, train, and validation splits, whereas with Palagemma, it dumps all of the images in a single folder, but it does have separate files in terms of annotations. And I'm going to pull up the annotations for test because they're smaller, but this is what the annotation file looks like. It has, it has the image sort of identifier, and then it has, it has what is the prefix, and that's how, and of course this is it's Palagemma, so it sort of has a true sort of description of what the model, when it runs, is supposed to look for. If this was Florence 2 in comparison, the only thing it's going to show is like OD, which indicates object detection, but it's sort of different in terms of approach. But anyway, there's the image, the prefix, and the suffix. These two models, at least in this context, are consistent in that approach. But I will.
Someone's asking in the chat if Florence 2 and Palagemma are competitors. So can you say what they do, those models, at all? Like, are they really competitors?
Yeah. So one of the vision language models that is also open source that people have heard of more is Lava. It's like LLAVA. If people are familiar with that, Florence 2 and Palagemma fit into that, the same space. What's a little bit different is that what Palagemma and Florence 2 can do that Lava cannot is do object detection.
So for example, if I have an image and I give it to any one of those, what can it do to me?
So once it's fine-tuned, it can tell you, help you detect where specific items, where specific blood cells are in the image and their type. And so, and here the three labels that the data set supports, regardless of what model you're trying to fine-tune, are RBC, like red blood cell, WBC, which is white blood cell, and platelets. And so that is what you are training. You're taking this data and you're training the model with it to become proficient
So your
at
input,
being able to detect it.
so your input after they're trained, you have an image, you give it an image, and it gives you those bounding boxes and tells you that's a red blood cell after training.
Yep.
Okay, good. So, and both of them can do the same thing?
Correct. Yep.
Okay, so now we understand. And so basically, those are both competitors in the market, kind of.
They're open source, so if it's open source, is it truly a competitor? So, but yeah. Yep.
Well, yes, there are alternatives for sure. Okay, got it. Okay, we answered that question. You can return to the code. I apologize.
That's great. Good question. I appreciate it. I cannot see the faces, so I can't see if people are making faces at me or not. So,
no one's making
okay.
faces.
All right.
In the chat.
All right. Okay. So at this point, what we have is, at this point in the code, we have the data sets in memory. So they aren't uploaded to Hugging Face or anything. And the next section is where we're analyzing the data sets. So, and in essence, just trying to understand, what's the high-level structure of the data sets that were created and how many rows. Part of the reason for wanting to do this is simply just saying, hey, is there consistencies when you try to use the Palagemma versus Florence 2 model when you're trying to download that specific format syntax, whether or not they're consistent. So yeah, and this is where it gets a little bit, again, diving a little bit deeper in terms of the nature of the data. I had to get the model to analyze this properly based on how they sort of, because in this case, because there is such variance in terms of what these models take for training, the big difference is Palagemma was simpler to analyze because it had a semicolon to break up the individual annotations, so the individual boxes in the image, whereas Florence 2 did not. So it's like if you want to, when you're trying to do this type of analysis, you need to sort of understand what you're looking at. And so what I ended up doing is, doing the analysis based on labels, because, each bounding box has a single label. So what I ended up doing was doing the counts based on, for this image, how many annotations are there based on the number of distinct labels. So, yeah, so I thought it would be helpful to use some of the standard data science-y graphs to sort of explain what I was trying to do. And then here is to start sort of being close, almost side by side or closer together to do the validation of, the same image ID, how is the data, how similar is the data, and what are some of the distinct differences. So when I was going through, and I'm not sure what struck me, step back and extract more than one at the same time, but I think that there was my sense that, that there were minor discrepancies, but until you really get the data closer together, it wasn't clear and obvious. Okay, so this is to the point of within the code of where I'm just doing a search, looking for the same image across, in the Florence data set and also the Palagemma data set, so that I'm only looking at a single record. And so this is what we touched on before. So Palagemma, it has this, in terms of structure, it has the label last in the individual instance. before the semicolon or Florence 2. It leads with the label, and the only obvious key that you have that a new annotation is starting is that you've got another label. As I said, one of the three. And then at the end, it's a push to Hugging Face Hub. So, and Hugging Face Hub, this is where one of the things that I like about in terms of discussions with Jacob is he always asks questions about, these are the newer ones, but I haven't fully annotated them yet. These are the existing ones. And so here, yeah, so always create a dataset card when you share something with Hugging Face. And although, okay, let me see. Is your favorite question? And it's okay. So yeah, so just because it's good practice and it's important. So as I stumble through this, is that the license that for this BCC data set out in RoboFlow is like creative commons attribution. And Jacob, you know the sort of definition of these more than I do, but for me, the essentials about this is that you can use it, but the essential thing is you got to give the people that shared it credit. And so in terms of using it in your research, this is a standard format in terms of how to share the data. So this was their request in terms of the format of what they're looking for in terms of when you share it, which is, okay, cite this project. So to me, this is just as important as the code, is that, how do you sort of cite it if you use it? And so that's the part here. In terms of what you share, it's bib text format and it's CC by 4.0. So the Creative Commons is, as I said, it's like, you gotta give credit is due.
We have a question in the chat. Sean is asking, there are so many LLM models out there. How did you know you wanted to use Polygemma?
Well, I was thinking that I actually decided against Polygemma, and that was because their tuning process was less open. So it's like one of those things in terms of large language or vision language models or large language models, even if they are open weights, as they often call it, like, you can fine tune it, you can sort of, even some of these open models, it's not like you can resell it, but one of the things that even if it's open weights, it's not open data, so it's not clear in terms of how they did the initial pre-training. So in fine-tuning, you had to use sort of an import of from Google as well. So it was just, to me, it just wasn't as desirable. It wasn't as open. It wasn't as similar in terms of, using the consistent Hugging Face libraries that I was used to. So it was like, that was another thing. It was didn't use like Path, LoRa, etc. And the Hugging Face type libraries it used.
It wasn't standardized. Did I say
it wasn't? Well, it's not that it wasn't standardized, but it was using standards that originated from Google. So
okay,
if that makes sense. Do you know what I mean?
Understand.
Yeah, exactly.
Okay, and Elliot is asking, what kind of license and cost factors are involved with these tools? So, for example, RoboFlow is under what license can you use it?
So that is that's like CC 4.0. So you can you can use it with attributions. But what I would say is that don't take my word for it. If you go to the point of you're looking to sell it, always follow up with the data set, model provider, etc. So that's even something that you'll see from Meta in terms of, I think it was Meta that I was recently looking at it for, is that, even if something appears open, still reach out to them for clarity on the specific use case.
Good advice. Thank you. Yeah, license is becoming more complicated today than software. Believe me, it's a good, what Don just told me, it's very good advice. If you want to actually do something with open source and sell it, yeah, contact whoever you use.
So that's it in a nutshell, the code. If we want to go into and dig into the fine-tuning process itself in detail, I can do that separately. One of the things that I will give you a heads up about is that it wasn't perfect. And let's have it open.
Here, show us. Take a, like, in nutshell, try to show us. If there'll be questions, we'll dig deeper.
Yeah, so this is like a sample of actually doing the object detection. So this is after fine-tuning. It's not going to tell you, it's not going to claim it's a jellyfish, but it is, one of the things that you'll notice is that it is coming back with some invalid results. So I think that is partially based on length and complexity, and the other has to do with some of the layers, like this is like, maybe, I'm not going to say it's an issue with RoboFlow, but RoboFlow, in terms of what it presents, it gives you this type of display when it runs the fine-tuning process. Like, it's already converting it to bounding boxes versus, and that's why I was thinking, okay, well, if I want to give people and teach something useful that people can take away from, that what it, Florence 2, once you fine-tune it, what it will try to predict, without, in the case of, say, you're trying to validate predictions using the test data set, right? So this is what the format that it actually will try to return. And so my sense was that there was issues with, when I did go to the extra effort of, what they're displaying out of the box in terms of their supervision tools versus, or what they were displaying with supervision versus what the model would return natively, was different. And so that seemed to be a contributing factor, is that there was a layer underneath that you needed to start looking at in terms of whether the model was able to predict accurately before starting to make a judgment. So so the reason that there's a reason underneath here that might be more valuable to kind of look at it. This isn't supervision, but it was like the exact same type of problem. It's like a layer above, where it's trying to convert from, sort of the native model specific format into sort of a more canonical bounding box format that most people and most sort of higher level sort of applications that might consume it are aware of.
Don, if Elliot is asking, actually Evgeny is asking, is it possible to estimate the accuracy in % of the obtained model?
Oh yeah, I had not had a chance to go back and validate it in detail, but one of the things I did share previously is the, I may as well just go to Makerspace's page. And yeah, so this is the confusion matrix. So it was imperfect in terms of its ability to,
How
predict
many
the right
records
thing.
did you try here? The 663 is for what?
That is, I was going to say
Oh, it's about
a
5,000.
thousand. Yeah, so I was going to say
Okay.
1,000, but
So
it's
everything
anyway.
in the
Yeah.
confusion matrix, if you can bring it back, anything
Yep.
not in the diagonal are errors. The diagonal are how many records were okay. So just from a big look, like 600 and something and 400 and something are off. This is the main data set. So it's probably 60% accurate, a little bit more maybe.
Yeah, and so this is in terms of the output, and it's not necessarily just supervision. I think it's also a shorthand that was created to display sort of this in a markup type format that is coded here. This is very early on in the process when it was still detecting jellyfish, but net is that why I didn't want to stare at this is because I realized that to improve behavior, what I needed to start doing was I needed to look at the lower level, like, and, evaluate the model's ability and be able to see the model's ability to accurately
Can you
predict.
zoom in a little bit? You're
Sorry?
saying it's detecting a jellyfish?
Oh yeah, an untuned. At the start when it's just starting, like the
Okay.
first epoch. Yeah. First.
Okay, explain to the people what the original model was for and what does fine tuning does to it, so they will understand what you're saying.
Well, I think one of the best ways to look at it is that one of the things that's distinct about Florence 2 is that the only thing it takes is a prompt. It's like a task-based prompt. Is OD. So you tell it you want it to do object detection, but you can't give it anything in terms of a prompt beyond that to help it sort of predict what it's seeing. And so that's why, in terms of, these sort of non-standard objects that finding a good fine-tuning data set is essential. So that's why it's like the things that had seen what was closest was a jellyfish.
So in the beginning, this image, the Florence will detect all sorts of objects like jellyfish, can be fish, can be anything else other than what the red blood cells. And then during the fine-tuning process, you're teaching it, no, those are red blood cells. Those are something else. Those are other types of objects. And you teach it by showing him the objects and explaining what they are. And then little by little, the machine learns the new terminology. Am I correct? Or is it something wrong, different?
Correct. It learns, it's all about features and labels, like things that people are aware of. Given certain features, it tries to predict, it gets better at predicting a label. And so here it's like the type of blood cell. Yeah. So the other thing that was interesting was that, and I think it could have been an issue with the test data set that it was being evaluated against, is that really the model on the training data set seemed to do much better. Maybe it's a little bit of overfitting, etc. But it's like, it was like before trying to do things. One of the critical things before diving deeper is like, pulling things apart a little bit and looking at sort of the direct output, also doing research to confirm that there wasn't anything wrong with the the specific data set that was used for validation. Yeah. So anyway, rambling, but that's part of the reason why I didn't want to go into this, is that there are layers and complexity here.
Yeah. Can you show the fine-tuning code that you're showing just a little bit, high level, not going into too much details about approximately what's going on there?
Yeah.
Because you use RoboFlow there as well, correct?
Yes. Yeah.
Okay. So show us where RoboFlow is used there and what is it?
Well, okay. So let's go back to the beginning. So in terms of the imports, so these are the Hugging Face libraries that are used, transformers and Heft being key ones for fine tuning, and then RoboFlow, the base library, and then the supervision library that helps with supervision. It's like, think of it as two words. That's sort of the advanced. The RoboFlow is kind of like the data set type stuff. Supervision is like the advanced tuning for vision models. Okay, and then so object detection inference. So this code here. It's not. So this isn't RoboFlow specific, but this is kind of generic inference. Given a single image, what does it predict out of the box? And so
where RoboFlow is used here.
Okay, well, so here, so RoboFlow, and I'm glad they had this morning here, but so it does things like it provides a bounding box annotator. And so in terms of given the information and applying the bounding box, that's one of the things it can do. It did not return the label, but it's just returning the bounding box it was creating was the entire image. Yeah. And so that is, okay, that's the data. Okay, this is the structure. Defining the structure. In fact, it is a JSON-L data set and the detection data set. If you want to know about stuff specific to, okay. Okay, and so it is, in terms of detections, etc. That's where it's drawing the boxes and it's doing the bounding box annotations, and so yeah.
Evgeny says it feels like a super difficult problem, probably even segmentation. Figuring out where bounding boxes are without classifying them would be non-trivial.
Well, I don't think it's difficult, but it's just here in terms of what it was predicting and the fact that there was issues. It seemed that so a simpler use case, like where it has fewer annotations, right? If it has where you're expecting it to only predict 3 or 4 bounding boxes, I think it would be fine. But it's like, you got to solve things step by step. So in terms of this case, it was like, one of the things I thought in terms of, and then I mentioned when I did my report, was that in terms of getting better results, it was one of the key things was find a simpler sort of use case, like the liver biopsy sample, where you're trying to find the diseased part, a diseased part in the entire image. So one sort of label that you're trying to apply in the image, as opposed to in some cases, I think that that was also sort of the value of this, is that I wanted to sort of go back and think about it as, okay, well, what is the distribution and how many annotations are in these images that we're trying to do the prediction against. So that's, yeah. So find a simpler one, perfect, like fewer annotations, perfect that, and then come back and fine tune it. And yeah, there's multiple variables. One of the other ones is that Palagemma and Florence 2 are both small models. Florence 2 actually quite a bit smaller than Palagemma. So it's like part of it may be that we're just exceeding, when you've got these many sort of items that you're trying to annotate on the image, that it might not be the best choice. Or else you need to take other sort of aspects. Like one of the things in vision that is often done with vision language models is you break it into sort of smaller patches. So it's fine, it's the perfect model for it, but you just need to take a different strategy. So
okay, do people have more questions about what Don showed, about RoboFlow, about other aspects of what he just showed? Don, do you want to show something else, or do we just want to answer questions at this point?
Let's just answer questions.
Okay, well, again, says it's a cool idea about splitting the image. Well, Evgeny, those models today are powerful. Machine learning is good, becoming really, really powerful these days. And Python is the entry language, or the ones used most to actually handle those models. Anyone has a question? You can voice it or put it in the chat. No questions?
Yeah. Well, I also think that in terms of the power of this type of model, like Florence 2, it wasn't perfect results, but often you do this because you're looking for something to prototype, or you're wanting to learn this at home, learn this on your own, apply the concepts, and then go back, seek funding in venture capital to build something grander, right? And so it's not about perfection, it's just about incremental improvement. And so, yeah.
I do have a question, Don.
Yep.
What if you didn't have RoboFlow? How much more work, or what exactly did you need to do to actually achieve what you achieved without RoboFlow?
I was close to getting to the same point with Palagemma, to be honest, but I was already sort of concerned about sort of the lack of openness and sort of the libraries that were being used to fine tune, where I had to pull other sort of data from that I didn't have full control over in terms of fine tuning. So, but yeah, I was close. The other sort of key tool, and when somebody else is talking, I can find his name, but there is a gentleman that works for Hugging Face but does a lot of YouTube posts, and who was simply brilliant. And he had a session on how to fine tune Palagemma, and I learned a lot from it. But I learned enough about it that it's like you need time, you need capital to fine tune a model that's not small. So it was like step back from it. And the interesting thing is that the folks from RoboFlow, one of the key guys that they cite and use code that they copy is this gentleman from Hugging Face. So, yeah. I'll find the name.
So how much time does it take to fine tune those? Like in the small versions that you use, how much time did you actually run the machine to fine tune?
The biggest thing there in variable is not so much time, but it's GPU. I would say that even with Florence 2 is a small model, but if I didn't have an A100, it would still often run out of memory. So that was vision models are finicky to fine tune.
So you need at least those 40 gigabytes to actually run. A100 is 40 gigs, if I remember correctly, correct?
Yep.
So you need those 40 gigs to be able to fine tune it. Yeah, this is actually most true for people ask about many LLMs. Even the tiny LLMs won't fit in your GPU, even if you have the big GPUs. So that's how it is. Anyone has more questions?
I had a question about like some of the more details on fine tuning, just from a beginner's perspective on what exactly we're doing to teach the LLM.
Yeah, Don, give us more stuff for beginners.
Well, I think that I'll share my desktop again. It's like it's the end of the day, so if I don't have my own visual cues, can't do it. So just a sec. Yeah, but great question. So what I would say is that we need to understand with fine tuning what the model expects, and sort of the various layers of what you're trying to tune. There's something called a collate function that sort of says how you sort of in a batch format, how you're taking the data and sort of while you're going through the process of fine tuning, how you're providing the info. But so part of the reason why I created this in terms of and why I respected RoboFlow and gave him full credit in the post about it was that to get to the point of understanding that when you are training that it takes both the image and the annotations to do it, and that each model that you're trying to tune, in this case this is Pelagemma specific, be helpful if I pulled up Florence too, since that's what we were talking about more in greater detail. But this is a key step. And so I didn't see a place where it had as clearly been sort of published that indicated that, when you're doing vision language model fine tuning, what exactly you needed to provide. This to me was what was difficult to get to this understanding that, each model needed something a little bit different, and what the specific format was the essential part. And like, even simple things like when you're trying to say, hey, well, what determines sort of a single record for, one annotation versus another. It's like, it'd be easy to think and assume that it's a semicolon based on what you saw for Pelagemma, but Florence 2 was completely different. So this is kind of what you need to understand. You understand this, and then it gets much easier to do.
Let me refine the question that was asked. If you now had a task of actually having those images, and you needed to start from the very beginning, find the model, what's the first few steps that you make? Even before RoboFlow, for someone who's actually beginning.
Well, okay, so you need to understand what I created a different app to do it, but I don't really want to bring it up. But you need to understand sort of in that use case, in that space, what models, what are your options, and then you need to figure out what are the specific variables in your sort of use case that may direct you to choose one versus the other. So I think part of it is that you need to do discovery. You need to do some quick examples and scenarios on a specific model, get to the point, have the experience of wrestling with Polygemma versus Florence 2 to figure out what is the right solution, if either. So yeah, it is very incremental, and one of the tools in terms of open source models is Hugging Face, and so you go out here to models. So what's the scenario you're trying to support? Like multimodal. Typical is like visual question answering. So that's like describe the picture, describe something about the picture. Object detection, segmentation is a little bit different, but you've got object detection as sort of a choice here. So if you filter on this, it'll give you some choices.
Each one of those is different.
Each one of those, yeah. So they're variants. Some of them are coming from Google. Other of them are things that have been tuned based on various models. The other thing that I would suggest is, let's see. Okay, that's like, did I delete it? No. One of the applications I was very impressed with was Landing AI. And if you know Andrew Ng, that's a company that he owns or is heavily invested in. And they have a sample app. And if you go through and look at their sample app, you can, you'll learn just so much sort of going through there. I had sort of, it's one of those things, sometimes you learn more and you understand things better having wrestled with the beast yourself. But, that in terms of the approach of what his team had built out, both in terms of, the fact there were two things to it. One was like, if we have any architects in the room, when you're doing trade-off analysis, like you have a specific requirement, what are the sort of options that you have to provide that capability, and then starting to narrow down, okay, well, based on details and specifics, figuring out your initial preference. So they were very good at that in terms of building up an app from scratch. The other thing that they weren't necessarily doing, but was sort of my sort of long-term vision for this project was, it's depending on what you're trying to detect. In some cases, it's not just one model's interpretation of it. You'll want one model that is effective at segmenting. You'll want one model that's maybe good at doing initial bounding boxes. You may want another model in camera perhaps, that's effective at heat detection. So it's like this sort of pattern, I think, is cool in terms of, don't think of it as one tool. Think of it as, depending on what you're trying to do, you may have a supervising agent going out and coordinating and getting information from multiple tools before making a final decision on what's detected or in the image. So.
Okay. Don, if it's okay with you, unless anyone has any pressing question, in which case I'll let them ask. If it's okay with you, perhaps we can stop the recording.
Absolutely.
Anyone has any pressing question? I'll wait. Questions going once. Question going twice. 3 times. No questions. So in that case, I would like to thank Don. Please, everyone, thank him. We have some claps and some emojis here. You can say, you can make some noise if you want. And yeah, people are happy. So I'm going to stop the recording now. Thank you, Don.